Namaste, nenu Shashikanth Valmiki from Saimedha Coaching Center, Koti, Hyderabad. So, my dear electrical technocrats, Tspsc AEE notification 15th September రాబోతా ఉంది. అయితే ఈ ఎగ్జామ్ ఎప్పుడు ఉంటుంది అని చాలామంది ఒక టెన్షన్ వాతావరణంలో ఒక క్వశ్చన్ మార్క్ పెట్టుకొని అంటే ప్రిపరేషన్ స్టార్ట్ చేయడము చేయకపోవడం ఇట్లా డిఫరెంట్ అట్లా ట్రాక్లో ఉన్నారు. వాళ్ళందరికీ ఒక చిన్న న్యూస్ ఏంటంటే ఈ సెప్టెంబర్ 15th రిలీజ్ అయ్యబోయే నోటిఫికేషన్ ఈ టీఎస్పీఎస్సీ ఏడబ్ల్యూ నోటిఫికేషన్ మ్యాక్సిమం 3 నెలల్లో ఎగ్జామ్ జరగబోతా ఉంది. 3 నెలల్లో కంపల్సరీగా గుర్తుపెట్టుకోండి, టైం వేస్ట్ చేయొద్దండి. సో టీఎస్పీఎస్సీ ఏడబ్ల్యూ దాంతో పాటుగా ఇమ్మీడియట్గా అంటే త్వరలో ఈ పాలిటెక్నిక్ లెక్చరర్ డేట్ కూడా రావడానికి అవకాశం ఉంది, గుర్తుపెట్టుకోండి. దానితో పాటుగా ఈ జెన్కోలో దాదాపు 200 పోస్టులు ఉన్నాయి, దీనికి కూడా నోటిఫికేషన్ రావచ్చు. మొత్తానికి ఈ 3 నెలల సమయం నుంచి స్టార్ట్ చేస్తే 1 సంవత్సరం లోపు ఈ పాలిటెక్నిక్ లెక్చరర్ ఒకటి, జెన్కో ఒకటి, టీఎస్పీఎస్సీ ఏడబ్ల్యూ మొత్తం టోటల్ అన్ని ఎగ్జామ్స్ కండక్ట్ జరిగిపోతాయి. సో మై డియర్ ఆల్ ఎలక్ట్రికల్ టెక్నోక్రాట్స్, ఒకటే మీకు చెప్పదలుచుకున్నా, మీరు రేపొద్దున ఏ నోటిఫికేషన్ ఎప్పుడు ఇచ్చి ఏ డేట్ ఎగ్జామ్ డేట్ ఎప్పుడు పెట్టినా కూడా దాంట్లో మీరు సక్సెస్ అవ్వాలంటే ఒక సిస్టమేటిక్ షెడ్యూల్ కావాలి. ఆ సిస్టమేటిక్ షెడ్యూల్ మన సాయిమేధ కోచింగ్ సెంటర్, కోటి, హైదరాబాద్ డైరెక్టర్ జేసీ రుద్రపాటి సార్ ఆధ్వర్యంలో, సార్ పర్యవేక్షణలో స్పేస్ ఇంజనీరింగ్ అకాడమీ ద్వారా స్పేస్ టీమ్ అంతా రెడీగా ఉంది. మార్నింగ్ 6 o'clock నుంచి ఈవినింగ్ 8 o'clock వరకు కంప్లీట్ క్లాసెస్తో పాటుగా అందరూ మీకు కోచింగ్ ఇస్తారు. ఇక్కడ మేము ట్రైన్ చేస్తాం. క్లాసెస్తో పాటుగా ఇక్కడ క్లాసెస్ ఒకటే కాదు, మెటీరియల్ ఇవ్వడం జరుగుతుంది. ఆ మెటీరియల్లో బిట్ టు బిట్ ఎక్స్ప్లెనేషన్ జరుగుతుంది. బిట్ టు బిట్ ఎక్స్ప్లెనేషన్ అయిపోయినాక ఎవ్రీ చాప్టర్కి రివిజన్ ఒకటి కండక్ట్ చేయడం జరుగుతుంది. ఎవ్రీ సెషన్ రివిజన్తో పాటుగా దానికి సంబంధించిన ఒక ఎగ్జామ్ కండక్ట్ చేస్తాము. ఎగ్జామ్ అయిపోయినంటే నా పేపర్ కూడా ఎక్స్ప్లెయిన్ చేస్తాం. దాని కొరకని ఇక్కడ కంప్లీట్ మార్నింగ్ నుంచి ఈ నైట్ 8 o'clock వరకు పెట్టాం. సపోజ్ 6 o'clock నుంచి 9 o'clock క్లాస్ జరిగిందంటే 6 to 9 ఆ క్లాస్తో పాటుగా రివిజన్ ఒక ఎగ్జామ్ టాపిక్ అయిపోతే, నెక్స్ట్ మధ్యాహ్నం మార్నింగ్ సెషన్ 9:30 స్టార్ట్ అయితే 12:30 వరకు క్లాస్ చెప్పి రివిజన్, ఎగ్జామ్, పేపర్ ఎక్స్ప్లెనేషన్. నెక్స్ట్ మధ్యాహ్నం 2 o'clock నుంచి ఈవినింగ్ మళ్ళీ సేమ్ క్లాసు, రివిజన్, మెటీరియల్, ఎక్స్ప్లెనేషన్, బిట్ టు బిట్ ఎక్స్ప్లెనేషన్, ఎగ్జామ్ పేపర్ ఎక్స్ప్లెనేషన్. ఈ విధంగా ఒక సిస్టమేటిక్ షెడ్యూల్. అంటే మీరు ఇంటికి వెళ్ళిన తర్వాత చదువుకోవాల్సిన పని లేదు. ఒకసారి మళ్ళీ మీరు రివిజన్ చేసుకొని పడుకుంటే చాలు, మళ్ళీ మార్నింగ్ వచ్చి క్లాస్ వింటే చాలు, క్లాస్ అటెండ్ అవుతే చాలు. సో అంత సిస్టమేటిక్ షెడ్యూల్. దాదాపు 8 మంది ఫ్యాకల్టీ అబ్జర్వేషన్లో మార్నింగ్ ఆల్మోస్ట్ 6 o'clock నుంచి ఈవినింగ్ 8:30 వరకు ఫ్యాకల్టీ కూడా ఇక్కడే ఉంటారు. కాబట్టి వాళ్ళ సహకారంతో మొత్తం స్పేస్ ఇంజనీరింగ్ అకాడమీ టీమ్, మన సాయిమేధ కోచింగ్ సెంటర్, కోటి, హైదరాబాద్ స్పేస్ ఇంజనీరింగ్ అకాడమీ టీమ్ అంతా రెడీగా ఉంది. ఆల్రెడీ బ్యాచెస్ స్టార్ట్ అయ్యాయి. ఇప్పటికి కూడా మీరు ఎవరైనా కోచింగ్ స్టార్ట్ చేయలేదో, కోచింగ్ తీసుకోవాలనుకుంటున్నారో వాళ్ళందరూ ఇమ్మీడియట్గా నా కింద స్క్రోల్ అవుతున్న నా నంబర్ కాంటాక్ట్ చేయండి. సో ఇంకొకటి ఏంటంటే మోస్ట్ ఎక్స్పెక్టెడ్ బిట్ సిరీస్ అని ప్రతి సబ్జెక్ట్కి కొన్ని క్వశ్చన్స్ మీకు ఇవ్వాలనుకుంటాం, శాంపుల్ క్వశ్చన్స్. ఈరోజు మన మోస్ట్ ఎక్స్పెక్టెడ్ సిరీస్లో ట్రాన్స్ఫార్మర్ వీడియో లెక్చర్ 1, మనకు ఈ వీడియో లెక్చర్ 1 చెప్పడానికి భానుప్రకాష్ సార్ అని దాదాపు కొన్ని 100 బ్యాచ్లు చెప్పిన సీనియర్ ఫ్యాకల్టీ ఆ సార్ ఇక్కడ ఉన్నాడు. సో ట్రాన్స్ఫార్మర్ మోస్ట్ ఎక్స్పెక్టెడ్ బిట్ సిరీస్ ఇప్పుడు సార్ ఎక్స్ప్లెయిన్ చేస్తారు. సో ఐ విష్ ఆల్ ద బెస్ట్. ఇంకొకటి ఏంటంటే మీరు మళ్ళీ గుర్తుపెట్టుకోండి, పడితే కాదు, ఎగ్జామ్ నోటిఫికేషన్ పడితే కాదు, ఎగ్జామ్ జరిగితే దానిలో మనం ముందు వరుసలో ఉండాలంటే మాత్రం మీ ప్రిపరేషన్ కొనసాగించాలి. ఓకే, కింద స్క్రోల్ అవుతున్న నా నెంబర్కి కాంటాక్ట్ చేయండి. మీకు ఫీజ్ డీటెయిల్స్ కానీ ఇంకా ఏ డౌట్స్ ఉన్నారో మీకు క్లారిఫై చేస్తాం. థ్యాంక్ యూ వెరీ మచ్.
Thank you, sir. So let me introduce myself first. My name is Banu Prakash, Faculty of Electrical Engineering in Saimedha Koti. So in this session I would like to discuss about some of the important questions or most expected questions in the transformer part. So let me discuss about one of the question, that basic concepts of the transformers. So let us read the question. First one, 2 windings of the transformers are designed as option A primary and secondary winding, and option B primary and HV winding, and option C secondary and LV winding, or primary and LV winding, and option D HV and LV windings. Okay, these are the options for this question. So transformer is designed with the 2 windings such as HV winding and LV winding of transformer. So basically, so this transformer is designed with 2 windings is designed with two windings. Such as one is a primary, one is a HV winding of transformer, okay, and second one is LV winding of transformer, okay. This is, so what is the mean by HV winding? So the winding which is connected to the, okay, the winding which has more number of the turns is known as HV winding of the transformer. So the winding which has the less number of the turns is known as LV winding of transformer. So these two windings, okay, treated as primary winding and secondary winding during operation of the transformer. But exactly what is the answer for this question? The transformer is designed with the two windings, so such as HV winding and the LV winding of transformers, okay. Let us solve the question number 2. The question is, transformer action requires constant magnetic flux, increasing magnetic flux, and option C alternative magnetic flux, and option D alternative electric flux, okay. So transformer action requires AC nature of the flux or time varying nature of the flux. So that means in order to induce the EMF in a transformer, what are the basic requirements? So that is a basic, the requirement. One is a, so stationary, okay, magnetic field is a magnetic time varying nature of the magnetic field is required. So that means flux should be time varying. So that is a phi of t is equal to, so phi maximum sin omega t. So this type of the flux is known as the time varying nature of the flux or AC nature of the flux. And second one is the set of conductors is also required, set of conductors. And third one is the relative time variation between the magnetic field and the set of conductors. So this is the relative time variation between the magnetic field and conductors or set of conductors. So these are the basic requirement to induce the EMF in the transformer windings. So one is the stationary time varying nature of the magnetic field, set of conductors, the relative time variation between the magnetic field and set of conductors. So what are the options given for this question? So one is a constant magnetic flux, okay, it is not at all correct. So next one, increasing magnetic flux, it is also not correct. So alternative magnetic flux, so that is the time varying nature of the magnetic flux. Alternative electric flux, which is not exist. So these which is option correct for this question? Option C is correct for this question, okay. Now let us solve the question number 3. So for understanding the behavior of the transformer, the following laws may be called for. One is a Lenz's law, the Newton's second law, Faraday's laws of electromagnetic induction, the induction, and this is Faraday's laws of electromagnetic induction, Ohm's law, the Fleming's right hand rule, so right hand grip rule. So this is a, what are the laws required? So first one, the transformer operates on the principle of the Faraday's laws of electromagnetic induction. So what is the principle here? So EMF induced in the transformer is directly proportional to the d psi by dt. So now this law is what? Faraday's laws of electromagnetic induction. So how do we find out this direction of induced EMF? Direction of induced EMF can be obtained by using, okay, Lenz's law. So now what is the Lenz's law? Effect opposes very cause producing it. So that means EMF induced in the transformer opposes the applied voltage to satisfy the Lenz's law. So that's why one more, this one is a Faraday's laws of the electromagnetic induction, okay, electromagnetic induction. Exactly it is a the second law. We have a two laws in the here. One is the Faraday's laws of electromagnetic induction. First law, Faraday's laws of electromagnetic induction. First law. So what is the statement of Faraday's laws of electromagnetic induction? So an EMF induced in a coil is directly proportional to the rate of change of flux linkage. So this direction of induced EMF can be obtained by using the Lenz's law. This is also required. And next another law is also given. So generally Ohm's law is required in the any case. So this is another requirement. And one more, to study the transformer part, right hand grip rule is required. That is the right hand. Okay, this one is the right hand thumb rule. Okay, thumb rule is required, okay, to study the transformer part. What is the statement of the right hand thumb rule? So actually this rule is used to find out the direction of the flux in case of the state conductor as well as a circular conductors. So in case of the state conductor, okay, if thumb indicates the current direction, then the orientation of the fingers around the conductor that indicates the flux directions. Okay, and in case of the circular conductor, orientation of the fingers indicates the current direction and thumb indicates flux direction. This is also, so what is the purpose of this law? Okay, it is required to find out the direction of the flux, okay, in transformer winding. And similarly Ohm's law is required, Lenz's law and Faraday's laws of electromagnetic. So this statement is correct. And next one, Faraday's laws of electromagnetic induction, the Ohm's law. So right hand, this Fleming's right hand rule or right hand grip rule. So this is not required. Okay, it is required in the DC generators or DC motors. And right hand grip rule. So right hand thumb rule is also called the right hand grip rule. So that what are the statements are required? 1, 3, 4 and 6 statements. So that option D is correct for this question. Okay. Let us solve the another question in this series. Question number 5. If a transformer primary is energized from the square wave voltage source, then its output will be option A 0 and option B sine wave, option C triangular wave and option D is a pulsed wave. So this is one of the important question from the basic concept. So how do we answer this question? First one, the transformer winding, okay. So this is the excited with the square wave voltage source, okay, square wave voltage source. Then what will happens? Okay, first one, the transformer is excited with the square wave voltage source. Then what is the shape of the induced EMF? So that means given that here, given this V of t, the supply voltage V of t is equal to the square wave, okay, square wave. So that we need to find out the shape of the induced EMF. So we know that transformer is inductive nature. Okay, this one is we know the transformer is a inductive nature. Transformer is, okay, inductive nature. So that the magnetizing current passes to the inductor. So therefore shape of the, let us find initially shape of the magnetizing current. So now this shape of the magnetizing current is equal to 1 by L, this integration of the supply voltage Vs of t, okay, dt. So this is the shape of the supply voltage. Vs is the supply voltage or applied voltage of the transformer. So now L is the inductance value. So now this is the square wave. So that this you can get 1 by L. So integration of the square wave. Okay, this one is a square wave. So with respect to the time. So integration of the square, we will get the triangular wave. So now this we will get, okay, it here. So this one is a triangular wave. So but we required the shape of the induced EMF. So that how do we find out shape of the induced EMF? So therefore, so here shape of the induced EMF E. So now we know that we know the current shape. So that LE is equal to, so L1, okay, D differentiation of the magnetizing current. So with respect to the time. So now this is equal to the L self inductance and differentiation of, okay, this is the triangular wave, okay, this T wave in the sense triangular wave. So with respect to the time, so that we will get, okay, this one is a integration of the square, we will get the square. So now therefore this is called the square wave, okay. Sometimes it is also called the pulsed wave also, okay. So now pulsed wave, some question we can ask the phase displacement also. So with 180 degree displacement, so this is the answer for this question. So that if the transformer is excited with a square wave voltage source, then the shape of the induced EMF is a pulsed wave with 180 degree displacement. What is the reason? So the phase displacement between the applied voltage and induced EMF is equal to 180 degrees. Okay. Let us solve the another question in this series. Question is the relative current directions through the primary P and secondary is the S of the single phase transformer connected to the resistive load on the secondary side, the indicated in the directions cross sectional views shown in the figures. The which of these are correct representations? Okay, this is the representation. Some the figures are given A, B, C, and some figures are mentioned, and also winding directions also given. So we need to find out which is the correct representation. Next, let's come. This is the first one. So let us discuss the first figure. So from option, okay, from the figure A. Okay, let's draw the figure here. So this figure, okay, this is a figure given. So one I have shown like this. So and next one, winding directions are mentioned like. Now similarly secondary side also given. So these are the windings directions, and primary side, okay, it is represented with a P, okay, it is represented with a P, and this one is the secondary side. And what are the current directions in the A figure? One is a cross in the P side. So left hand side is a cross, and this one is a dot. So that, okay, let's give the figure. So this one is a cross, okay, and this is a dot is a given. So cross and dot, and secondaries, in the secondaries, so this secondary side is a cross and dot is given, cross and, okay, this one is a cross and this side is a dot. So cross and dot representation is nothing but the current directions in the winding. So that is a current entering, and this is in this case the cross means, okay, what is the meaning of the cross? The cross is the current entering directions. So this is the current entering position. Now next one, what about the dot here? So dot is a current leaving the leaving position. So by using this, okay, we can find out the flux direction. So now let us find the flux. So already have mentioned that, so direction of the flux can be obtained by using right and thumb rule. So how do we obtain this direction of the flux here? So this is the cross mark and this one is the dot mark. So current entering and leaving positions in the primary side. So if the orientation of the fingers indicates the current direction, then thumb indicates the flux direction. So in this winding, in the primary winding, so what is the flux direction? The flux here, so this is a direction of the flux, okay, this is the direction of flux, and this flux I can say that phi 1 flux, okay. Now similarly in the secondary winding, So this secondary flux is also same direction. So now this is a secondary flux phi 2. So now this is the primary flux pi 1. So now according to the Lenz's law, the secondary flux must opposes the primary flux, so that this figure is a correct one. Okay. So this option A is the correct. Let's verify another one. Suppose we have another figure. Suppose here this is the cross mark, right? So we have a cross, okay, this is a cross and this one is the dot. Now similarly this one is the cross and here is a dot is given. So what will happen in the primary side? So cross, the mark indicates always current entering position, dot mark indicates current leaving. So orientation of the fingers represent the current direction, then thumb indicates the flux direction. So this flux is the pi 1 flux, okay. Now similarly, what about the secondary side? So this is the direction of the flux, okay. So direction of the flux is this is the direction of the flux pi 2. So now these two are, so pi 2 in this figure also pi 2 opposes the pi 1, okay, here pi 2 opposes pi 1 well. So this is also correct one. Now let's verify here. So this is the cross and dot, so that this is the primary flux pi 1 and secondary flux, two dots are given, so that, so this is not at all correct, and here the primary flux is a pi 1 and secondary flux is also, so this is the direction, okay, secondary flux is a phi. So now this pi 1, okay, pi 2. So in this case pi 2 in phase with the pi 1, but here pi 1 and pi 2, okay, pi 1 and pi 2 both are, so I will, so this point pi 2 opposes the pi 1, so that in this question, so option A and option B both are correct, okay. So these are the some most expected question for AEE Tspsc exam. So already batch is started, so that please join as early as possible to get the initial benefits in the preparation of the your exam. So thank you.